Alright, this video is on abbreviated electron configurations. This is mainly going to focus on elements 1 through 20, which is going to be exclusive to the S block and the P block for our electron configurations. Now, in class, we are aware of the D block and the F block, but this is not going to be involved in this video. So what we're going to focus on is using the already ground state electron configurations that we know how to make and know how to draw out, and then we will abbreviate it, and it'll be pretty easy. So first thing we're going to do is we'll need to do an orbital diagram, okay, and we'll go ahead and pick element 1, nitrogen. Okay, so we're going to pick nitrogen. Nitrogen has 7 electrons, okay, so important to know how many electrons nitrogen has, right? And because it's a neutral atom, we know that it has 7 electrons because it has the same number of protons, and the atomic number of nitrogen is 7. So I'm going to do my orbital diagram. So I'm going to make my 1s, I'm going to make my 2s, and then I'm going to make my 2p box. And the reason why I'm not going past 2p is because I know when I look at the periodic table, I know nitrogen is let's see if we can erase this little section right here. I know nitrogen is right here, right? In that little green box. Right? I know nitrogen right there, and that is in the second energy level. All right. So continuing on, let's go ahead and fill our energy, or fill our orbitals. So first we have, right, our first s orbital, and then our second s orbital. And then I'm going to have, so right now I have 1, 2, 3, 4 electrons, and then 5, 6, and 7. So remember, I'm not going to do this, right, when I have my my p orbital here. I'm not going to do this, right, because if there's an opportunity for all the orbitals to be at least half full, they will be, because that is a more stable state. And obviously, if this is a ground state, that is the most stable state. So this is our orbital diagram, and from this we can get the electron configuration, or the ground state electron configuration. So I have 1s, and there are 2 electrons in here, 1s2, and then I have the 2s, and there's 2 electrons in there, 2s2, and then in the 3p orbital I have 3 electrons, so that'd be 2p3. That is the long, even though it's not that long, the long version of nitrogen. All right. So the abbreviated, or the short electron configurations are only going to be dealing with you're really focusing on the highest energy level. Okay. And what I mean by that is you're going to take like in this case with nitrogen, the high energy level is, or the highest energy level is 2, right? The second energy level, right? Now this right here happens to be the electron dot diagram for the only passed, or the only noble gas that you passed in your process of getting to the electron configuration that you have, and this happens to be helium's electron configuration. All right. So because this is helium's electron configuration, all you really have to do in order to do the abbreviated electron configuration is, instead of drawing the 1s2, you do a helium, and you put it in brackets, and then you just continue on with the rest of the electron configuration. This right here would be considered the short version of that. Now you're thinking, well, that's not that short, because instead of writing 1s2, I wrote helium. And yeah, that's true, because when it's such an element with a small atomic number, there doesn't have that many electrons to begin with, right? But let's pick another. Let's go ahead and take a look at another one. So this time, let's take a look at well, let's say potassium, which is right here, number 19. Okay, we'll take a look at potassium. Right? So potassium has a grand total of 19 electrons, and I know that potassium is in the 1, 2, 3, fourth energy level. Okay, so I'm going to have to make a 1s2, or sorry, a 1s orbital, a 2s orbital, a 2p orbital. That's a horrible orbital. Let's try that again. All right, a little better. All right, so there's my 1s, my 1s, my 2s, 1s, 2s, 2p, right? And then I'm going to need a 3s. Yeah. Right? Hey, come on now. 3s. And then I'll need a 3p, but it's in the fourth, so I actually need a fourth s, because I know that's in the s block, right? So I have a 4s. So I'm going to fill in my electrons. So filling in my electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So there's my 19 electrons. Okay, and from this I can get my electron configuration. So I just count them off what I have. I have 1s, and I know there's 2 electrons in here. Okay, and then 2s, there's 2 electrons in here. 2p, and there's 2, 4, 6 electrons in here. So 2p6. And then 3s, there's 2, so 3s2. 3p2, 4, 6. So 3p6. And then 4s1. 4s1. Okay? Now, if I wanted to do the abbreviated electron configuration, what I need to do is I need to find out, well, what noble gas did I pass? Okay? So the most recent noble gas that I passed, if I look up at this periodic table, right, would have been in, since this is in the fourth energy level, I need to look in the third energy level. So what's my noble gas in the third energy level? And that would be argon. So, as it turns out, this whole thing is argon. So if I was to draw the abbreviated electron configuration, all I would do is put the most recent noble gas that I passed, in this case argon, and then put whatever's left, 4s1. And this would be the abbreviated electron configuration for potassium. So you either can write it in the long version, which is the green written out, or the red written out, which is the abbreviated electron configuration. Okay, so you should be able to do that for any of the 1 through 20 elements. Okay, so let's go ahead and do one more. And of course, when I say we, I mean you. Okay, what I'd like you to do is I want you to give me the orbital diagram, long electron configuration, and the abbreviated electron configuration for calcium. Okay, or not calcium, magnesium. Magnesium, right here. This guy right there. Okay, so go ahead and pause the video and work that out, and then I will show the answer when you're done, and hopefully we're all good. All right, so let's take a look if you got the right answer. Okay, so we're looking at magnesium. Hey, that's an eraser. Looking at magnesium, which has 12 electrons. Okay, I know it has 12 electrons because it has an atomic number of 12, and the magnesium atom is neutral, so the electrons and protons are equal. So, looking at 12 electrons, and then now I need to look at what is my highest energy level. In this case, would be 3. So, in this case, I'm in the third energy level and the S block. So I'm going to go. There's my 1s. There's my 2s. There's my 2p. And then my 3s. That's it. Okay, so let's go ahead and go through our electrons, right? I need 12. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's my 12 electrons. Okay, so my long electron configuration is going to be 1s2, 2s2, 2p6, and then 3s1. Well, if you look right here, this is the electron configuration for neon. And then, oops, all we do here is go 3s1, or excuse me, 2. 3s2. And that would be the abbreviated electron configuration for magnesium. Now remember, if you're having difficulty identifying, looking at this right here and say, oh, that's neon, if you're having difficulty just seeing that and seeing neon, look at your periodic table and look at your noble gases. When you're counting as you go across, right, you're eventually going to stop. Well, go look at the most previous noble gas, and then you'll write that noble gas in the brackets. Okay? So if you guys have any questions, please ask in class.